The second path begins where Arduino leaves the classic 5-volt AVR world. Well, Due and Zero introduce 32-bit ARM processors into official Arduino boards. Nano 33 later folded several modern architectures, radios, and sensors into the compact Nano form. Nano Matter continues that movement toward secure, low-power connected devices built around Thread, Bluetooth Low Energy, and the Matter ecosystem. These boards do not belong together because they share one processor. They belong together because they ask the same first discipline. Their external logic operates at 3.3 volts. A module that felt harmless beside an Uno can become dangerous here when it returns a 5-volt signal. So this video is about more than speed. It is about a new electrical boundary, native USB, finer analog systems, debugging, wireless communication, and software stacks that reach further than the old AVR core. Keep the transition clear. More capability, more attentive contact. Due gives a large field of I/O. Zero makes 32-bit debugging approachable. Nano 33 turns the Nano outline into several different connected platforms. Nano Matter enters a shared smart device language. The familiar Arduino workflow remains, while the silicon underneath changes completely. Arduino Due marked the moment when the familiar Arduino form expanded into a 32-bit ARM system. Choose it when a project needs many pins and substantially more processing power than the classic 8-bit boards can provide. It suits fast data acquisition, advanced robotics, motion control, 3D printer or CNC experimentation, audio and waveform work, multiple communication channels, and large prototypes that benefit from real analog outputs. The Due keeps the extended mega-style shape, so the board offers a broad field of headers and room for complex wiring, but the resemblance can be dangerous when it creates false confidence. Due uses 3.3-volt logic. Its I/O pins are not 5-volt tolerant. A shield may physically align with the headers and still place an unsafe voltage against the controller. That is the lesson held beneath its familiar outline. Physical fit is not electrical consent. The board gives more speed, more memory, more analog capability, and more interfaces. In exchange, it asks for more careful attention to signal levels and library compatibility. Stay with that boundary. Keep the contact soft, precise, at 3.3 volts, because the Due becomes powerful, not when every available connection is used, but when each connection respects the quieter electrical world in which the ARM controller is designed to respond. At the center of the Due is the 32-bit Atmel SAM3X8E with an ARM Cortex-M3 core running at 84 MHz. The board operates with 3.3-volt logic and must not receive 5 volts on its I/O pins. It provides 54 digital input and output pins, 12 of which support PWM. 12 analog inputs connect to an ADC capable of 12-bit resolution. For compatibility, Arduino analog read begins at 10-bit resolution until the sketch selects 12 bits explicitly. Two DAC outputs generate true analog voltages within the DAC's limited output range, rather than producing only PWM. Memory includes 512 kilobytes of flash and 96 kilobytes of SRAM. There is no EEPROM in the classic AVR sense. Communication resources include 4 hardware UARTs, 2 I2C interfaces, SPI, 2 CAN controllers, a native USB OTG port, and a separate programming USB path through an ATEM MEGA16U2. Both CAN controllers require external CAN transceivers before they can touch a physical CAN bus. The board exposes JTAG and includes reset and erase controls. Let those specifications arrange themselves: more power, a lower, stricter voltage, 32-bit execution and 84 MHz create room for heavier computation. The many headers create room for large systems, yet the 3.3-volt boundary remains close, clear, and essential to every safe response. Arduino Zero brought 32-bit ARM capability into a board closer to the familiar Uno shape. Its role is different from the much larger Due. The Zero is suited to embedded learning, low-power systems, wearables, responsive robotics, smart sensing, native USB devices, and projects that need more memory and computation without requiring dozens of headers. One of its most useful features is the onboard debugger. Instead of guessing through messages and LEDs, supported tools can pause execution, inspect variables, place breakpoints, and follow the program closely. That changes the relationship with an error. The system no longer has to remain a sealed surface. You can stop it, look inside, hold the state, let the hidden moment remain open, and observe what the code was doing at a precise moment. The Zero also offers a real DAC output and higher resolution analog measurement than classic AVR boards. But once again, the Uno-like outline does not mean Uno-like voltage. The Zero uses 3.3-volt I/O and is not 5-volt tolerant. Choose it when debugging. Low power, native USB, or the SAMD21 ecosystem serves the project, and when every connected signal is prepared to meet that lower voltage boundary safely. It is a bridge toward the wider SAMD family, where many modern Arduino-style boards share related peripherals, power concerns, and debugging methods. The Zero is based on the ATS-AMD Ch.1 G18, a 32-bit ARM Cortex-M3 Plus microcontroller running at 48 MHz. It uses 3.3-volt logic. Applying 5 volts to an I/O pin can damage the board. The controller provides 256 kilobytes of flash and 32 kilobytes of SRAM. With no true EEPROM, 20 digital I/O pins are exposed, with 10 commonly available for PWM. 6 analog inputs connect to an ADC capable of 12-bit resolution. Arduino analog read defaults to 10 bits for compatibility until the sketch selects 12-bit operation. One pin provides a 10-bit DAC output for a real varying voltage rather than only PWM. Native USB device and host capabilities are built into the SAMD21. The board includes UART, SPI, and configurable serial communication units. A separate eDBG interface provides programming, a virtual COM port, and hardware debugging without an external probe. That combination makes the Zero more than a faster Uno. The architecture, memory model, peripheral mapping, interrupt system, and voltage are different. Portable Arduino code may cross easily. AVR register code will not. Keep the layers aligned, same outline, a new interior unfolding beneath it. The Zero preserves an approachable physical form while opening a 32-bit path toward debugging, native USB, finer analog work, and lower power designs. Arduino Nano 33 is not one single board. It is a family built around the compact nano form and 3.3-volt logic. Nano 33 IoT is shaped for Wi-Fi connected sensing. Nano 33 BLE and BLE Sense variants are shaped for Bluetooth low energy, motion sensing, and embedded machine learning. Choose Nano 33 IoT for small cloud-connected sensors, secure network devices, mobile dashboards, environmental monitoring, and compact projects that need Wi-Fi as well as Bluetooth. Choose a Nano 33 BLE variant when low-energy wireless communication, stronger local processing, or tiny ML matters more than Wi-Fi. Sense versions add microphones and environmental or motion sensors directly on the board, allowing a prototype to observe sound, movement, proximity, temperature, humidity, pressure, or color with fewer external modules. The small form is inviting, almost ready to disappear into the finished object. But every Nano 33 shares a warning that must remain visible. Its GPIO is 3.3 volts and is not 5-volt tolerant. A classic Nano module may fit physically beside it, yet deliver a voltage the newer board cannot safely accept. So before the compact shape draws the circuit close, protect the boundary and let the contact stay safe. Identify the exact Nano 33 variant, then choose sensors, libraries, and signal levels for the processor actually inside. Nano 33 IoT uses a 32-bit SAMD21 Cortex-M3 Plus running at 48 MHz with 256 kilobytes of flash and 32 kilobytes of SRAM. It operates at 3.3 volts and is not 5-volt tolerant. The board exposes 8 ADC-capable analog positions, although A4 and A5 contain I2C pull-ups and are not recommended for ordinary analog measurements. It also includes a DAC output, a 6-axis IMU, an ATE-CC608 secure element, and a NINA W102 module for Wi-Fi and Bluetooth. Nano 33 BLE and BLE Rev 2 variants use the Nordic NA RF52840, a 64 MHz Cortex-M4F with 1 MB of flash and 256 kilobytes of RAM. They also operate at 3.3 volts and provide Bluetooth low energy without Wi-Fi. Their A4 and A5 pins likewise carry I2C pull-ups, so ordinary analog use is not recommended there. BLE Sense versions surround that controller with additional sensing for motion, audio, pressure, humidity, proximity, light, color, and gesture depending on the exact revision. The processors are different, the radios are different, the Arduino platforms and library expectations are different. Keep the names separated, small form, several interiors waiting beneath. Nano 33 is a doorway into modern 32-bit embedded work, but the exact suffix tells you which memory, radio, sensors, and software world will answer. Arduino Nano Matter. belongs entirely to the newer generation. It is not merely a general-purpose nano with a radio. It is shaped for connected devices that must join a matter ecosystem, communicate across a thread mesh, and use Bluetooth Low Energy during discovery and commissioning. Choose it for smart home controls, lighting nodes, environmental sensors, building automation, low-power products and prototypes that must cooperate with Matter platforms. There is no Wi-Fi radio on the board. Its Matter traffic normally moves through thread over IEEE 802.15.4, while Bluetooth Low Energy provides the nearby path used to introduce the device to the network. Bluetooth mesh is a separate capability of the radio, not the transport used by Matter itself. The compact nano form lets the controller settle inside a finished device, while secure vault hardware protects keys beneath the surface. USB-C provides power, programming, and data. Dedicated test pads expose JTAG and SWD debugging directly, but the exposed logic belongs to a 3.3-volt electrical world. 5-volt signals must not touch its GPIO directly. Hold that boundary clearly. Keep the connection gentle, exact, and safe. Nano Matter is designed not merely to sense or control, but to enter a secure conversation between devices, quietly, efficiently, and through a shared language already prepared. Nano Matter is built around the Silicon Labs MGM240S D22VNA, a 32-bit ARM Cortex-M3 controller running at 78 MHz. It provides 1,536 kilobytes of flash and 256 kilobytes of RAM. The exposed I/O operates at 3.3 volts, even though the board itself may be powered through USB-C, the 5-volt pin, or VIN. Wireless support includes IEEE 802.15.4 thread, Bluetooth Low Energy 5.3, and Bluetooth Mesh. Matter communication on this board normally uses thread, while Bluetooth Low Energy is used for discovery and commissioning in the current Arduino workflow. Secure Vault hardware provides protected security functions for connected applications. The board exposes 22 GPIO lines. Its controller includes 20 12-bit ADC channels and up to 4 12-bit DAC channels, although the board pinout determines which channels are physically available. 2 UARTs, 2 I2C interfaces, and 2 SPI interfaces are supported. All exposed GPIO can provide PWM, with no more than 5 PWM channels operating simultaneously. An onboard RGB LED and user button provide immediate interaction. USB-C carries power, programming, and data. Dedicated test pads expose JTAG and SWD debugging. Pause at the density. Small form, many layers, one quiet pulse. Radio, security, analog functions, debugging, and application logic meet inside one compact board. Now let the 3.3-volt generation settle. Not as identical boards, but as several paths beyond classic AVR. Due gives a large project many I/O lines, faster computation, CAN, and true analog outputs. Zero brings the SAMD21 into a smaller form, with native USB, finer analog work, and onboard debugging that can pause the program and hold its hidden state open. Nano 33 compresses wireless communication, sensing, and 32-bit processing into several compact variants. Nano Matter goes further into secure connected systems, thread carrying the conversation, Bluetooth Low Energy opening the first introduction, Matter giving devices a shared language, different processors, different radios, one shared boundary, 3.3 volts. Keep that limit close. Let safety make the contact deeper, because restraint is not distance. A clear boundary allows the signal to enter, remain clean, and return without harm. More memory may tempt, more speed may excite, but voltage decides whether the first touch is welcome. 3.3. Soft and exact. Protect the line and let it connect. In the next video, the direction changes again. Arduino keeps newer processors and richer peripherals, yet returns to 5-volt GPIO through Nano every Uno Wi-Fi Rev 2 and R4, preserving a familiar electrical world while the architecture underneath becomes new.